In this video, we will perform a variety of transformations. We're talking about reflections, translations, rotations, and dilations. In the previous video, we have already done problems 1 through 8 of this lesson. So we are going to pick up with problem number 9. Alright, so this will probably end up being more advanced overall than the previous video. But if you didn't watch the previous video, you might want to go back and watch that first. Throughout this video, I will be constantly referring back to this set of rules, which I am assuming that you have memorized. So if you have not memorized these rules for reflections and rotation around the origin, please pause the video and memorize these rules right now. Alright, so problem number 9. Draw the image of segment GH after it is reflected across the line y equals 2. Okay, the line y equals 2 is a horizontal line at 2, so keep that in mind as we do this. So we need to draw a horizontal line at 2. Okay, that's the line y equals 2. So now we need to do a reflection over that. So notice how point G is 2 above the line, so I will go 2 below. So here is point G prime. Notice that point H is 1 above, so I will go 1 below, and that will be H prime. Okay, so that's how you would do number 9. Number 10, we need to do a 90 degrees clockwise rotation around the point H, which is 1, 3. So the point H is the center of rotation, not 0, 0, not the origin. So first of all, please understand that we cannot use these rules directly. Now, I'm going to show you how to do this algebraically and graphically, so you can choose the method that you prefer. So first I'm going to show you how to do this algebraically. So the point G is the point -2, 4. So I've got the point -2, 4. It's my original point G. The point H is 1, 3. So when you do not start off at the origin, what you have to do, if you're going to do it algebraically, you have to move the graph to the origin and back. So right now we are rotating around the center 1, 3. That's not the origin. So we're going to modify all of the points involved, sort of so we can pretend like this is 0, 0. So first you ask yourself, what would it take to turn the center into 0, 0? And what it would take is you would have to subtract 1 and subtract 3. That would turn the center of rotation into 0, 0. Then take that and do it to everything. So I'm going to do -1 and -3 to all of the points that I want to rotate. So -1 and -3. So this will move these points to be sort of revolving around the origin instead of revolving around H. So this will become the new point -3, 1. And this will become 0, 0, because that is the center of rotation. Okay, now that we have moved the points to revolve around the origin, now we can apply our rules. So that's our next step. So we're doing a 90 degree clockwise rotation. So 90 degrees clockwise, that's where a general point xy will become y negative x. So we reverse them and change the sign of the x value. So that's what we'll do now. We'll reverse them and change the sign of the x value. Okay, of course that won't do anything to 0, 0. Alright, which makes sense because that's the center of rotation, so that's not going to move. So we moved to the origin, we did the rotation, now it's time to move back. And the way you move back is by undoing what you did at the beginning. So at the beginning I subtracted 1 and subtracted 3, so now I will add 1 and add 3 to move everything back the way it was. So add 1 and add 3. So this will give me my final answer. So I will go ahead and call this G prime. So this will be 2, 6. And this will be H prime, which will be 1, 3. Alright, which of course is the original point. H didn't move since we're rotating around point H. Okay, so that's how you would do this algebraically, and so notice that we would end up G prime would be at 2, 6. Alright, so that would be 2, 6 would be right here. So this would be our G prime, and then we just would draw that, and then H prime would be right here as well. Alright, so that's how you would do this algebraically. You move to the center, you change the center to the origin, you do the rotation, and then you move everything back, and then that's your answer. Now here's how you would do it graphically. So graphically we're going to use pathways. H is the center of rotation, so focus on that. And of course, because H itself is the center, it's not going to move when we rotate around it. So all I really have to worry about is point G. So look at the pathway from H to G. The pathway goes left 3 and up 1. So what I need to do is rotate this arrow 90 degrees clockwise. Clockwise is in this direction. So if I rotate the entire arrow 90 degrees, this horizontal 3-piece is going to become a vertical 3-piece. And then that little vertical 1-piece will become this horizontal 1-piece. So that's so now I've rotated the arrow 90 degrees clockwise, and now the new arrow is pointing at the point G prime. Okay, and that's it. So if you're comfortable with that, it is quicker than doing it algebraically, but some students really struggle to do that mental rotation that I just did. But notice G prime is at 2, 6, which is the same thing we got algebraically. Alright, so it works either way. And of course, this original point H is also the point H prime. Alright, let's move on to number 11. Draw the image of segment GH after it is dilated by a scale factor of 3 from the point 0, 5. So, I'm going to do this in a similar way that I did the previous problem. I'm going to show you how to do it algebraically, and it's going to look a lot like this. And I'm going to show you how to do it graphically, and it's going to look a lot like what I just did right here. Alright, so, but we're talking dilations. Look, if we were dilating from the origin, all I would have to do is take these original points and multiply by 3. So again, I've got my original point G, which is -2, 4. and I've got my original point H, which is 1, 3. Okay, so if I were dilating from the origin by a scale factor of 3, I would just multiply all these by 3, and then that would give me the answer, and I'd be done. But we are not dilating from the origin. We're dilating from this point 0, 5. So using the strategy that we used last time, we're going to move to the origin, do the transformation, and then we're going to move back to the origin and back. So what would it take to change this point to the origin? Well, I've already got a 0, so all I would have to do is subtract 5 from the y value, and that would make this into 0, 0. So I'm going to do that to all of my points. So I'm going to subtract 5 from this y value, and I'm going to subtract 5 from that y value. In this way, everything will be back to sort of revolving around the origin again. So this will become -2, -1. And this point will become 1, -2. Alright, so now we're revolving around the origin. So now that we're back to the origin, we can use our normal rules for dilation. Now I can simply multiply everything by 3, okay, because we're back at the origin. So I can do that dilation multiplying by 3. So maybe I'll just put times 3 right here just to indicate what I'm doing. And then I'm going to get -6, -3. Alright, just multiplied by 3. And I'm going to get 3, -6. So now I've done the dilation. Alright, now it's time to move back where we came from. So in order to do that, I need to undo the -5 that I did before. And I will undo that by adding 5. And this will give me the final answer. So this will be G prime. And that's going to be -6, 2. And this will be H prime. And that's going to be 3, -1. So that's it. I would just graph these guys. -6, -2 is going to be right here. Alright, and that is my G prime. And 3, -1 is going to be right here. And that is my H prime. Alright, that's it. That's what the answer would look like. So that is how you would do this algebraically. Okay, now let's see how we would do it graphically. Alright, I'm just going to start all over again. So graphically, first you have to pay attention to what is the center. So the center is 0, 0, 5. So this is the center point right here. So what I'm going to do is I'm going to draw the path from the center to a point, and then I will dilate the path. So from the center to point G is left 2 and down 1. So I'm going to dilate that path. So since the scale factor is 3, I need to multiply everything I just did by 3. I need to triple it. So instead of going left 2, I'm going to go left 6. Instead of going down 1, I'm going to go down 3. Okay, so I'm going to triple this. So I'm going to go left 6 and down 3. So that should be my G prime. Alright, I just tripled the path. Some of my students like to look at this as doing the path 3 times. So they would go left 2 down 1, left 2 down 1, left 2 down 1. They would just do it 3 times and you get the same thing. Maybe I'll do it that way for H. Okay, notice g prime is negative 6 comma 2. That's the same thing we got algebraically. So again, I accidentally erased my center, which is 0, 5. Is that right? 3, 4. Yeah. Okay, so the pathway to H would be right 1 and down 2. Okay, that's the pathway to H. So if I want to triple that, that means I need to do it 3 times instead of 1 time. So so right 1 down 2, that's 1 once. Okay, right 1 down 2. Okay, now I've doubled it. Right 1 down 2. Now I've tripled it. I've tripled the path. So this should be the location of H prime. Okay, notice that this is 3 comma negative 1, which is the same thing I got when I did it algebraically. Okay, so that's 2 ways to do problem number 11. Alright, problem number 12. Pick all of the transformations that would map this figure onto itself. It could be more than one. So a reflection over the line y equals negative x. So when you're thinking of mapping a figure onto itself, you should be thinking about, well, if you're talking about reflections, you're thinking about the axis of symmetry. So this is the line y equals negative x. Is this an axis of symmetry for this square? In other words, does it cut right through the middle of the square? Do I have mirror images on either side of this line? And yes, this is an axis of symmetry. These are mirror images on either side. So that is, that reflection would map the square back onto itself. So I'm going to circle that one. Okay. I think I'll do all of the reflections at the same time. So let's think about the reflection across the line x equals negative 3. Okay, x equals negative 3 is a vertical line at negative 3. So is this an axis of symmetry for the square? Yes. This splits the square right down the middle, with the left side and the right side being mirror images of each other. So yes, a reflection over that would cause the square to fall back on itself again. So that is another winner. So I'm going to circle that. Okay, how about a 90-degree rotation? Okay, let me get rid of my line here. Okay, so here is my square. If I do a 90-degree rotation, is it going to look any different? No, it's going to still look the same. Look, I can do that rotation right now for you. If I rotate this 90 degrees clockwise, and that's to the right, bam, I just did it. You could probably not tell that I just did it because it still looks the same. Rotating this 90 degrees doesn't change anything. So that will map the figure onto itself. Okay, I need to be more careful. It says 90 degrees clockwise around the point negative 3 comma 3. Is this point in the center of the square? Because the rotation I just did, I was rotating around the center of the square. Alright, I wasn't rotating around 0 comma 0. So is this point at the center? Let's see. If I go to negative 3 and then I go positive 3, that is the point right here. Okay, so what I just said was true. Rotating around this point 90 degrees, it still looks the same. But if this had been any other point, if it had been the origin or any other point, then this would be false. This only works when you're rotating around the center of the square. Okay, and that's why this last one, if I were to rotate 180 degrees around the center of the square, negative 3, 3, that would again look the same. But if I rotate 180 degrees around the origin is way over here. If I rotate 180 degrees around that, my square is going to be over here. Okay, that's what it's going to look like if I rotate this 180 degrees around the origin. Okay, that's a big change. That is not mapping onto yourself. So we're not going to choose that one. Alright, the other three were good. Alright, we're up to 21 minutes, so that's long enough for this video. But there's still yet more to come. Alright, I think we should be able to finish the rest in one more video, video number 3. I think. I don't know, still a few problems to go. So we'll see. We'll see if I can finish this in one more video. But take a look at the next video, which will start with problem number 13. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.